Good morning, everyone. Today we're going to be looking at lesson 3-4 together. Make sure that you saw my note on Google Classroom today. I had asked that you pull up the new lesson. I posted it there for you to print. I tried to simplify the notes that I put together for you yesterday, and I was crunched for time a little bit, so I felt like they got a little bit too detailed. As it is, there's still going to be some detail here, but these notes that I edited for you today are posted. So if you did not get those, I want you to pause the video and go pull up Google Classroom, and in the comments to the class, I posted the new lesson notes. So please go do that. If you have them, we'll go ahead and get started. Today's lesson, the objective is that by the end of this, you'll be able to identify and describe arithmetic sequences. And yes, that is spelled like arithmetic, but it is pronounced arithmetic. So arithmetic sequences is what we're going to be talking today about. So let's go ahead and get a few vocabulary terms identified. First of all, we're going to be talking about a sequence. And so a sequence is an ordered list of numbers that often forms a pattern. Often forms a pattern. Sometimes it doesn't. The term of the sequence is simply any number that is in your sequence. An arithmetic sequence is a number sequence formed by adding a fixed number to each previous term to the next term. That's wordy, so I'll show you what that means. Okay, so let's go ahead and look at letter A down here. We have a sequence of numbers here, 26, 39, 52, and 78. I'm going to rewrite them because I want to spread them out just a little bit. So I have 26, 39, 52, 65, and 78. The question is this ordered list an arithmetic sequence? Well, let's see what the difference is in between each one of these numbers. 39 minus 26. If you do that in your calculator or in your head, you'll figure out that the difference is 13. From 39 to 52, the difference is 13. 52 to 65, the difference is 13. And 65 to 78, the difference is also 13. 13 is a very special number when we're talking about arithmetic sequences. Number 13, in this case, is called our common difference. Common because it's defined for all the differences of all those numbers in between each one of those terms. So we call it a common difference, which, as you will see in our formulas today, we call D. Letter B. I just want you to think of a sequence a certain way. I want you to think about a sequence as a function for just a moment. Let me get to my notes here. I wrote a few things down I didn't want to forget to say. All right, so we're going to think of this sequence as a function with a domain and a range, where the domain is restricted to, let's just say, natural numbers. You don't have to write this down, not this part. And the range are the terms in the sequence. So in other words, the numbers in the sequence. I'm going to abbreviate sequence there. Okay, now this part I do want you to write. So we're going to say that, hold on a minute here, let me find my other notes. There we go. Okay, so we're going to write something that looks like this, A of n, okay, where the value of n, the value of the nth term of a sequence. And I'm going to see if I can squeeze that in here. There we go. Okay, so A of n represents the value of the nth term of a sequence. Okay, so it could be any term in your sequence. I'm not saying the first term, the second term, the fourth term. I'm saying the nth term. So any term that's in your sequence. Now I could say, okay, well, I want to know what the first term is. So I'm going to put A of 1. And what is it in our sequence up above there? The first term is 26. Okay, and right under here, you may have more room because I squeezed in some other things here. write that that represents the first term of your sequence. Okay, you could also have a of 2, or a of 3, a of 4, a of 25. I mean, you could have many different terms put in here depending what your sequence is doing and how far it's going. Okay, so a of 2, and this would be, in our sequence above, is 39. Okay, and this represents the second term. And if you think about this as a function, I want you to think about f of x. You don't have to write this either, but I'm just going to write this off to the side. F of x, let's look at this, equals, let's just say it's, I don't know, f of x, some term over here, but it's going to be y, okay, because it's, excuse me, no, not y. Might be x. There's the parent function that we talked about the other day. But anyway, I wanted you to notice that what's happening here with the 1 and 26 is really like a set of coordinate pairs. Whoops. Yeah, 1 and 26. And the other one is 2 and 39. So if I actually wanted to plot these on a graph, I actually have a set of ordered pairs that I can do that with. Don't write that down. That's not necessary to have in your notes. Okay, and neither was this really. I just wanted to make sure I said that to you. Okay, now let's go up to C. What is a subscript notation? Because that's just another way that we can represent a term in a sequence. For example, I could say a sub 2 here, and that is equal to my second term, which we said was 39. Okay, and again, this is my second term in the sequence. So the second term is 39, is exactly what that means. Okay, I wouldn't actually say a sub 2. I would say the second term is 39. Okay, now today that's the first thing. We wanted to go ahead and just kind of get some understanding of what sequences are and the parts of a sequence. And now we're going to talk about two different types of sequencing for formulas that we're going to learn. So we're going to learn two formulas. One is called the recursive formula. The other is called the explicit formula. And what we're going to figure out about these is, first of all, the recursive formula is used to find only the next term in a sequence, okay? Whereas the explicit formula, and you see that I have these here, the explicit formula will find any term, so the nth term. So it doesn't have to find just the next term. This formula will help us identify any term in the sequence. And we're going to see this in action here. So we're going to start off by looking actually at an example. And if you look in your books, you should have your books there. If you don't, please go pause the video and go grab it. And come on back. All right, so we're looking at example 2 here. It's on page 112. And you see this picture of a pyramid. Now I have this drawn out on your notes looking like stair steps, and I'm going to go back to that in just a minute. But just to give you a picture of what's going on here. So here's a pyramid, has many steps there in the middle of it. It tells us that each step is 26 centimeters tall, and we're going to use the recursive formula to find out some information about these steps. So let me scroll back up to my notes. Here we go. All right, so here's my steps. My steps don't look like the pretty ones in the pyramid, but just for the sake of an example in your notes, let's go ahead and fill in the information that we just learned. We know that each step is 26 centimeters tall from the ground. Okay, so each one is 26, and you can just put a 26 here. And I have it kind of going into the line above it because those stairs, I don't know how many are there. It's hard to see in the picture, as you can tell. But they continue beyond just those 4 steps. It goes on and on and on up to the very top of the pyramid there. Okay, now you notice off to the left here, I have this little A with a subscript of 1. And what that means is this is the first term. Notice how it has a little 1. That 1 indicates that this is the first term of the sequence. Okay, so we're going to write a sequence here using our formula and find out some information about some things. The recursive formula, you're going to notice it's right here. You notice it right there. I have it written there next to recursive formula. I wanted it there so it's easy for you to reference. And I wrote it again down next to our example because I want to identify some parts of this. So let's look at the first term. So you see this little n right here? that says, now we notice in the top one there, A with the 1, that was representing the first term of a sequence. But when you see N, we're just indicating this is a formula that we can use for any term in a sequence. So really when you see the formula without any actual numerical values, the formula is just written as a standard formula to represent all kinds of situations. Okay, but the N represents, it's still the number, the placement of your term in your sequence. But at this point, we don't have, in this formula, we just want to know that this N represents the nth term. So it's any term we're trying to find, the nth term of our sequence. This little subscript right here, this N minus 1, obviously would be the term before the one that we're mentioning in the front end of our formula. So it's the previous term, right? So for example, just to kind of throw something there, don't write this down because I'm going to erase it. But let's say we are looking for the fourth term of some sequence. Then I would need to know, okay, so N is equal to 4, so I'm going to put 4 minus 1 here. So really, what does that mean? That's A sub 3. Okay, now watch what happens here. So D is that common difference that we talked about. Write that right up here. That is meaning by what numerical value is each number increasing or decreasing, depending, in my sequence. Okay, so back down to this little example, that little 4 minus 1 there. If I'm looking for the fourth term, if I know the term before it and I add my common difference to it, I'm going to be able to determine what the value of what my fourth term in my sequence is. And we'll see this in action as we go along. Okay, so let's go back to our stair steps here. So back to the step example, the first term in our sequence would be 26, right? And actually, we're going to write this a little bit differently, so erase that out of there. I want you to actually write this as A sub 1, or the first term is 26. Okay, and below this, we're going to write our formula again so we don't lose sight of it, and the more we write it, the more it becomes solid in our minds. So AN, or the nth term of a sequence, equals the previous term plus D. Okay, and the question here is, what is the height above the ground of the second step? So now what we're looking at, and you can see very clearly what it is, but what we're looking for is, well, what is this height? Well, you would just say, well, it's 26 times 2. That's easy, right? So you already know what your answer is going to be here, but let's use the formula because sometimes we don't have a nice picture. We don't really know what is being represented. We're just given a sequence of numbers and we have to figure some things out. And sometimes some of the terms are missing and you have to know how to find those. So the formula is extremely helpful in finding. Now remember, this formula is used only, and you might want to highlight this up here, the next term in the sequence. That's going to be the major difference between the recursive formula and the explicit formula. The recursive formula only finds the next term in your sequence. All right, so here's my formula written down here now. So what do I need to know? So what's the height above the ground of the second step? So we always want to know, okay, well, we said the first term, or the first step, the first term in our sequence is 26. Now let's use our formula to fill in some information. Let me think for a moment here. What did I write here? Let me go back to my notes really quickly. Just bear with me for a second. I don't want to miss something that might be really important. Oh, okay. We're going to fill in what we know here. I know that a sub 1 is 26. I know this, okay? But I want us to kind of work through this for just a moment. I also know that the difference, the common difference, which we said is d, is also 26. Now, that has nothing to do with my first term because my first term is not always going to be the same as my common difference. In this case, it is because each stair step is 26 centimeters. So my first term is 26. Okay, so we see that every time this moves up, it's moving up at 26, right? That's our common difference. Our first term is also 26 in this example, but not always does it work out that way. And you'll see that. I think we have a later step example that's not going to work out exactly like that. Okay, so in this, I want you to see how we're going to figure out that a, the first term is 26 by using the formula. So we go with our a, I'm trying to find the second step. So we're going to put a 2 in place of n. I'm going to fill in a, now remember n is 2. So look what happens here. So the second term is the previous term plus my common difference. So it is my previous term plus 26. And look, we already know that our first term is 26. So in this case, the previous term is going to be 26. So over to the side here, there should be enough room for you to just finish this up over here. We're going to go ahead and plug in or substitute for A1 is going to be 26 plus 26. So the second term in my sequence is actually 52. Okay, and like I said a moment ago, you could look at this example up top here by looking at the stairs and say, well, my second step, the height from the ground up through my second step is 52 centimeters. I can continue to do that, continue to add on the 26, right? So let's look at the third step. Now we just figured out that the second term in our sequence is 52. So we're going to use that right here. I want that to be written at the top here. But now we're looking for the third step. So we're going to call that a with a subscript of 3 equals a2 plus our common difference, which was 26. I'm doing a step at a time here. Let's fill in a2. We said it was 52 plus 26. So our third step or our third term is 78 centimeters. Okay, so that's how you would figure those out. That's how you use that. Now, let me see if I want to bump over to trying. I think I'm going to hold all the try-its till the end. Let's go ahead and get the information put out to you. Now, let's bump over to the explicit formula. The explicit formula looks slightly different, and the reason it's written slightly different is because it is set up to help us find any term. Because think about it. Back in the recursive formula, I had to know the previous step or term in my sequence in order to get the next one. And that's the way that works. You have to go like a term at a time. It's kind of redundant. So we're going to look at this now and see how we can find any term in our sequence. All right, so the first thing I'd like for you to do is we're going to identify some parts of this, just like we did on the other side here. So let me blow this up just a little bit. Okay, so the n here represents the term number. Remember we said a with the little 1 for a subscript is always the first term of your sequence. Right up above here, if you can squeeze this in, I should have left a little bit more room here. I want you to write in there, this is our previous term. Right, because the term minus 1 would be the term just before it. Okay, and n, again, just like we said over on the first part of this equation on the left-hand side over there, n will represent the same thing throughout the problem. That's just the way algebra is. Okay, so that is your term number there. And then, of course, the d, we said, is the common difference. That is how the sequence is changing. And that should sound familiar to you when you think about a function. The rate of change, right? What's the rate of change is our slope. Okay, so there again, we see this kind of like a linear function. All right, so we're going to have this example. And by the way, this can be found in your book on page, the very next page, 113. So just look over there. It looks like this. You can fill in the chart from there. Boop, boop. Here we go. Right there, we're going to fill in that chart right there. 1, 2, 3, 4, and then fill in the rental costs, and we'll talk through this. Let's go back to my notes. Go back to the table. This first part, this is like your X value, by the way. This is your number of days rented. And this is about a bicycle place, okay? So the cost of renting a bicycle is what's given in this table. The question is going to be, how can you represent the rental cost using an explicit formula? So the second row here is going to be the rental cost. So for 1 day, the cost is $26. For 2 days, it's $38. For 3 days, it's $50. And for 4 days, it's $62. So let's see if we can determine what the common difference is here. So going from 26 to 38, so 38 minus 26 is 12. How about this one? 50 minus 38 is 12. So it looks like we do have a sequence here with a pattern. It's increasing by 12. Now remember, 26, let's circle that because that is our first term, which we write as A with a little subscript of 1. And the 12s, remember what that is, that's our common difference. All right, so you get a picture of what's happening here. And let's write off to the side here that we know then, since we know the common difference is 12, let's just write that right here. So D, remember I told you in our formulas, D is always representing the common difference. In other words, how the sequence is actually changing. In this case, it's changing by an added number of 12 for each term. Okay, so it's increasing by 12 each time. Okay, so we're going to write down the formula again for the explicit formula right underneath here. So n equals the first term plus n minus 1, which is the previous term, times the number of the common difference. All right, now let's fill in. We're going to substitute in what we know. Okay, we know that A1 is 26. Okay, this is for the nth term. I'm not actually solving here just yet for the actual, for an actual amount of days. We're just writing like the generic formula for this specific problem. Okay, so this formula can be used, once we get this formula set, this formula can be used to find any term in your sequence. So let's continue writing this out. So I have 26 plus n minus 1 times the difference, which we know the common difference is 12. Okay, so let's go ahead and finish this by simplifying it. I'm going to have 26 plus, I'm going to have to do some distributing, and it looks like it's kind of backwards. So you're going to take n times 12, which is 12n, and then negative 1 times 12, which is minus 12. And I can do one more little calculation here to its fullest simplification. 26 minus 12 is 14 plus 12n. Okay, so here is the formula that we are going to use. I'm actually going to box it in so I can see it a little bit better. Now, I am going to use this formula to find out the cost of renting the bike for 10 days. So let's rewrite the formula that we just came up with for this particular sequence using the explicit formula, and we're going to fill in what we have here. So we're looking for not just an nth term now. Now we have a term that we're looking for, and it's going to be the 10th term. Equals 14 plus, and we said n is going to be the same value throughout our problem. So we want to put a 10 in right there as well. And we get 134, and that would actually be dollars, wouldn't it? So for the 10th term, or for 10 days of renting my bike, it would cost me $134. Okay? So you see, I couldn't have used the recursive formula for that as nicely because I'd have to go one term at a time until I got to the 10th term. Well, who wants to do that? So in this case, the explicit formula turns out very nicely for us. All right, now, in the next section, what we're going to learn how to do is to go back and forth between each formula. How can I, if I'm given a problem that gives me the recursive formula, can I transform that into the explicit formula? Well, yes, I can. So let's see how we do that. And then on number 4, you see over there, we're going to go from explicit to recursive. Okay, so we're kind of going back and forth. So in the first problem, we start off with a recursive formula. And it says we have a with a subscript of n. So the nth term equals the previous term plus 4. And we're always told with the recursive formula, we're going to be told what a1 is. The first term is 7 here. Okay. So let's write down what we know. From this particular formula, we know that the first term is 7. And we know that the common difference is 4. Okay, that's right here, positive 4. Okay, so those 2 pieces of information are very important. And by the way, this is the next word problem that you can see. If you turn over to page 114 in your book, you're going to see we're working through a problem there. They actually have it visually set up for you. And I have just kind of a sketch here where we're going to draw in what we have. The first step, and you're going to want to make this step just slightly longer. Oops, let me get black here. Make this stair step look a little bit longer simply because it is. The first step is actually 7 inches tall from the ground to the next step. Okay, and then each recurring step is going to be 4 inches according to our story, our problem here, the words given to us. Okay, so here you're going to see where your first term is going to vary. It's going to be different from your actual pattern in your sequence thereafter. So let's see what we can figure out. But there's a way to use this formula to help us out. Now remember, well, first of all, let's write let me see. We're going to write the explicit formula. Hold on one moment. AN equals AN minus 1. Okay, we're good. Alrighty, so on step number 2 here, we're going to write the explicit formula. So if you need to look back up at your notes, or you can just follow along with me, but the nth term is equal to the first term plus the previous term times the common difference. So let's fill in what we know. In this case, we know that the first term is 7. We identified that from our recursive formula. Plus n minus 1, and the common difference is 4. So this, my friends, is actually your explicit formula. Okay, so I used my recursive formula and took some information out of there that could be used into my explicit formula. Keep in mind too, something I want you to, and I said this just a couple minutes ago, but I want you to realize that when you're given the recursive formula, you always will have the first term given to you. So when we are going to be working backwards from an explicit formula in just a minute to go to the recursive formula, we need to write not just the formula, but we also have to write what A1 is, which is your first term, which you'll see in just a moment. So let's bump over to number 4, where we have the explicit formula, and we're going to go to the recursive formula. Now watch with me closely here. The first thing we want to do is identify what the common difference is. Now it is in that formula. This is written as an explicit formula up here. It might look different to you than what we just wrote. Like it looks like it has less terms, but that is because they're actually giving you the first term in this in the formula up front. Let me just peek at something here. Okay, well, let's kind of break it apart. So let's identify, first of all, what is the common difference? Now, this is kind of backwards. So how you would have seen this, and let's kind of bump up. I think I want to go up and find where we did an explicit formula here. Okay, see this explicit formula right here? 14 plus, no, not right there. I'm sorry. This one, right here. This one. Okay, see how it is 14 plus 12n? We started with a larger formula right here, right? And we ended up with that smaller formula. That's what is happening down here. Okay, it's given to you in its final form down here as the nth term equals 1 plus 1/2 times n. Okay, so let's identify what the difference is. The difference here is going to be 1/2. Okay, and if I go back up here, if you look in your notes, flip them over and look, the difference was 12. See that over here in the original formula is D, and then in the second line you can see I filled in 12 as my difference. Okay, and then it gets added together with the first term. Okay, so don't let this confuse you. You're going to think to yourself, but this doesn't even look like what we've been working on. It is. I'm going to walk you through this so you can see it. Okay, so off to the right here, we're going to write this just so that you can see that the nth term equals 1 plus, I want you to write it this way, 1/2 n. I'm sorry, I want you to turn it around the way that we've been seeing it. So you would have n times 1/2. Okay, but remember, you can multiply in any order. It still is the common difference. So that means your sequence that you can't even see yet, but the sequence is moving consistently at a rate of 12. Okay, so each term is having, a half. So each term is being added by 1/2. Now the second step here, we want to find the first term of the sequence. So we're going to write down what we're given up here. We have 1 plus 1/2 n. Oh, and by the way, go back up here and just circle that. Okay, now we're going to fill in. We want to find the first term, so we're going to, instead of the nth term, we're going to find the first term equals 1 plus 1/2 times 1, because that's what we said n is going to be equal to here. And then finally, off to the side here, we can just write the first term is equal to 1 plus 1/2, which we know is going to be 1.5, which turns into 3/2. So here's our first term. Okay, now we have enough information to write the recursive formula. So what does the recursive formula look like? Well, it's the nth term equals the previous term plus D. So let's write down the formula so we can get used to knowing what it is. Don't skip that. And now the formula, the generic formula for the generic recursive formula for a problem that has a first term of 3/2 and a difference of 1/2 is written like this. Okay, so remember, we just went from explicit to recursive. And remember what I said a moment ago? You always have to, let me scroll over here for just a second. Look right there, off to the left, where I just put that arrow. Remember I said you have to always tell with it what the first term is, because I can't solve anything without the first term. Okay, so there, and I'm going to connect these two so you know that that's the answer right there. All right, so that is the lesson. So let's see if we can apply some of these things that we learned. First of all, the first try at number 1 problem says, is the domain of the function in part B of example 1 continuous or discrete? I'm going to scroll back up there and we're going to take a look at it. And part B, let me see what that was. Actually, it's in your book too, if you want to look on page 111. At the top is part B. It's basically the sequence. Here we go. Up top here, the very, very top, I'm looking up here at our sequence 26, 39, 52, and so on. Okay, is it discrete or is it continuous? Now remember, you might be thinking, I can't even remember what the difference between continuous and discrete is. Now, don't draw this, but actually I have blank paper down here, so let me go down here and use this. Remember that you could have a situation where you're driving your car and you're using gas, okay? And if you're traveling at a certain rate for a certain amount of time, you might say, okay, well, in 1 hour, I've used 1 gallon of gas. In 2 hours or so many miles, I've used this much gas. And it could go on and on and on. That would give us a continuing line from right here, okay? And they connect because the gas continues to flow out of the car. So as the gas decreases, it actually will decrease to even values in between each one of these points, doesn't it? It's not going to like all of a sudden like hold a gallon of gas and then spew it out in an hour. And then in the next hour, it's going to hold all this gas and spew it out in the next hour. That's not how the gasoline in a car works, right? As you drive, it's continuing to use the gas. So that would be considered a continuous oh my goodness, I can't even spell. Okay, that is a continuous function. Okay, whereas if I eat, let's just say in 1 hour, I eat 1 full cookie. In the second hour, I eat 2 full cookies, and so on, okay? These are not going to connect, right? I'm not going to, if I tell you I'm actually eating that cookie right there on the spot, I'm not chewing it for an hour, taking little bites and taking little bits of pieces off every 15 minutes. If I say I eat a cookie 1 hour and eat another cookie or 2 cookies in the next hour, I'm not going to connect anything because there's not a time that I'm going to eat 1.5 cookies. I'm actually going to eat the whole thing. I'm going to plunk it in my mouth and it's going to be done. Okay, so now let's think about this in relationship to our situation here. I have to think about the elements of the domain and what the domain consists of, okay? So in this case, if you think about, I could think of this as subscripts, for example, or it's referring specifically to B, so we're talking about right here. Okay, so when I fill in a value for the first term, or the second term, and so on, the first term is always going to be 26. The second term is always going to be 39. There's no term in between there. Okay, so on my graph, that's going to actually have specific points that I'm going to mark. 1, it's going to be at 26. 2, it's going to be at 39. Say it's up here. Right? 3, it's going to be at 52. It's going to be up here. Okay, but I'm not going to connect it because there's no values mentioned in between here. Okay, so this would be considered a discrete function or a discrete function. We can call it a function. So let's go down. Here's what you're going to answer. It's discrete. To write the reason, here's what you're going to say. The elements of the domain, and I'm going to put that as a big D because we're going to use that in just a minute to finish this up, are the subscripts, right, which was kind of like the X value. So the D, or the domain, consists of only natural or counting numbers. Okay? There's nothing in between. Okay? It goes from 1 to 2 to 3. There's no points given in between. Okay? So that on a graph would just be like dots. You would not connect it as a line. Oh, you might see it as a dotted line. As a matter of fact, if you turn to page 113, you can see it right there. Let me go down there real quick. Right here. Okay, you can see it plotted right there. And actually, you can even see what the function is here, 12x plus 14. Okay, so they used 12, which was your common difference, as your slope. 14 is your y-intercept. But at any rate, which is right here. Okay, at any rate, you can see the dotted line indicates we're not going to connect those because they are not a continuous function. It is a discrete function. All right, so let's go back to, whoops, and I'm probably making you dizzy here. All right, let's look at try it number 2. Hey, Mom, are you okay? Hello? Okay, then she must have dialed me by accident. All right, so let's look at try it number 2. We're going to write a recursive formula to represent the total height of the nth stair above the ground if the height of each stair is 18 centimeters. Okay, so if you envision what we had up here where we had these stair steps, this is what we're talking about, the recursive formula. So let's start off by writing the recursive formula. The nth term equals the previous term plus the common difference. Let's fill in what we know. And we're only writing this for the nth stair. That's what it said right in the problem. So we're not given a specific stair. We're just going to write what the formula is for the nth stair. All right, so the nth stair equals A, which represents the previous stair, plus what is our common difference? Well, if the height of each stair is 18 centimeters, that's our common difference. And that's how you write that. Try it number 3 says the cost to rent a bike is $28 for the first day plus $2 for each day after that. Write an explicit formula for the rental cost for n days. What is the cost of renting the bike for 8 days? All right, so we have n, the nth day or the nth term of our sequence is going to equal, let's write the formula. It's the first term plus the previous term times the common difference. Let's fill in what we know. So we have the nth term equals, okay, now what is the first term? The cost to rent a bike is $28 for the first day. So there's our first term. Plus, and we don't have any information for this yet. And the common difference is going to be kind of what your slope is, or like the constant rate of change, or how much is each term increasing. In this case, it is 2. So we continue to simplify this. We have 2n minus 2. The nth term would be 28 minus 2 is 26 plus 2n. Okay, so there is the formula. Now, the second part wants to know what is the cost, or how much would it cost to rent the bike for 8 days. So now we have a little bit more information. So over on this side, let's go ahead and write what our new formula is. As we simplified, our explicit formula, it came to this. So let's fill in what we know. We're looking for the 8th term. So the 8th term is 26 plus 16, which will give us $42. And there we have it. All right, now let's practice the try it number 4. And I want you to write right here so we remember what we're doing. Here's what we're doing. We're going to be writing from recursive to explicit. If you look in your books for try it 4, you can find it on page 114. It's in the middle of the page. It wants us to write an explicit formula for each arithmetic sequence. So we're given the recursive formula for letter A. It starts off like this. This is the recursive formula. And we are told that the first term, remember I said in a recursive formula, we always figure out, or will be told what the first term is. All right, so let's turn this into an explicit form. Okay, do we see here? Let's also pull out of this information, what is the common difference here? Well, it's -3, because in the formula for recursive, if you go back and look at that form, let me go back up here. See where I circled the 4 up here in number 3? Remember, that is your difference. That is what the sequence, how much a sequence is increasing by or decreasing. And in this case, we see that it's decreasing because it's decreasing with a negative number, -3. So that means your sequence is subtracting 3 for each term. So let's write here that we're going to change this now into explicit. I'm just going to kind of abbreviate it there. So let's write down what the explicit formula looks like. The nth term is equal to the first term plus the previous term times the difference. And then we just substitute in what we have. So we know that the first term here is 10. We're told that right up here. And we know the difference is -3. So we tack that on to the end. Now let's do some simplifying. 10 plus, oops, that's going to be minus because we're going to be subtracting here. Right, I'm distributing right here. N times a -3 is going to give me -3n. And -1 times a -3 is +3. Now I can put some terms together here, can't I? I have a 10 plus 3. So I'm going to have 13 minus 3n. And that, my darlings, is your explicit formula. Okay? Now let's look at B. B is another one. Actually, you know what? I'm not going to do that one with you. Let me have you do that by yourself, and then when you come to the Zoom call, if you still need help, I'll be happy to help you. Let's bump to example 5. Example 5, we're going to now be going from explicit to recursive. Okay? Write that in there so you don't forget at any time what we're trying to accomplish here. The problem that we are given is in the final explicit form, and we have 8 plus 3n on this side. So let's see what we can pull out of this. Now remember, I'm going to bump back up here just as a reminder. Remember what we said right over here when we look at this one that's up here? Remember I said that the common difference can be found next to the multiplication of n. So coming back down to our problem, what is that number? Looks like the common difference is 3 right there. Common difference. Now, we need to find the first term because I don't know what it is. And I need the first term in order to put this back into, remember, in the recursive, I had mentioned to you that you always will be told the first term. In fact, I'm going to just remember how I said in the recursive, you're going to come up with a formula and you're going to tell what the first term is. So in this case, I have to know what the first term is, but I don't know it. So I have to know how to find that. So right here, I just want you to put find first term. Okay, so we're going to write down, how do I find the first term? Well, the nth term was a with a little subscript of n, so now I want to actually put 1 in there so I can find the first term. So anywhere else in my formula where I see n, I'm going to plug in my 1. So I have 8 plus 3 times n, right there it is. I'm going to put 1 in there. So the first term is 8 plus 3, which is 11. So over here, I'm going to say my first term is 11, and I'm going to box it in. And I'm going to keep on going. So now I'm going to write the recursive formula. And if you don't remember what it is, go back and find it. It's the nth term equals the previous term plus d, right? So here we know that d, we already know, is 3. Wait a minute, why do I have 8 there? Hold on 1 second. For some reason, I put an 8 in there on my notes, and I don't know why I did that. I think I got lost somewhere. Let me check something right quick. Bear with me. Hold on. 3. I don't know where I did that from. I don't know. Anyway, this is correct. Okay, and I want you to attach those because the final answer is putting it into recursive formula, and also the first term is always mentioned when you write the formula. You always have to say what the first term for that formula is going to be. And that, my friends, actually finishes up the lesson. I'm going to leave B for try it number 5 for you. So you're going to go ahead and try that problem on your own. And the ones that you're going to do for your homework, I know you're thinking, oh my goodness, that was so long. Why do I have homework? But I won't see you again until Tuesday. So you have several days to finish your homework. Your homework is going to be in your book on page 116. And you are going to do numbers 19, 23, 25. And some of these are just easy questions, like does it look like it's a arithmetic sequence or not? 29, and 29, by the way, is going to be for honors if you want to do it. If you're a level 1 algebra student, that's fantastic, and you can do that for a bonus. Honors students, you are required to do it. 31 and 33, 35, 37. I think there is 10 problems here, including the honors. Okay, so that'll give you lots of practice on these problems. Plus, you're working on finishing up the lesson, part 2 lesson from yesterday on 3-3. Zoom call will be at 2 o'clock. Oh, yeah, okay. I'm thinking, oh, well, you're already here with me, but we're not even there yet. Okay, Zoom call, 2 o'clock today. If you need help, please come. I will see you there. And thank you so much for watching. I'm sorry that this took so long. Again, these lessons are built in for 2 days, but we're on block schedule, so we never have that time. So sometimes the lessons do get a little bit lengthy. All right, guys, for those of you that I'll see at 2, I'll see you then. Otherwise, I will see you on Tuesday. Hopefully, you all will come. Have a great afternoon. Bye-bye.